Hi, everybody. Welcome to the class today. Uh, we're going to see today how there's sort of a shortcut for the big process that we did on Friday, the Gaussian elimination. And with the graphing calculator, we can do that process. But first, I want to show you. Actually, first, I want to ponder this question. I want you to ponder it. That process we learned on Friday, Gaussian elimination. There are pros and there are cons to it. Would you type into the chat? What do you think? You could say pro is this, con is this. Are there any pros and cons you could think of about that process from Friday? Okay, and I see one pro from Ethan. It is a lengthy process. It seems like it's longer than the elimination method. Even for a 3x3, it really took a long time. So that is a con. Is there any pro that anyone could think of? Okay, and I see there that it's always going to work. Although the other methods also always, always work in that, like the elimination method also works. But it is, it does work. It does get us the answers. And there's this idea of the upper triangular. So getting it into upper triangular, it's nice. Like once it's there, it's real straightforward how to continue. Okay, anything else about a pro? Because so far, the cons seem to outweigh the pros. We have, it gives us the right answer, and that's good. But so did the other ways, and it's really like long, and it's really cumbersome, and it's hard. Tedious is the word I was looking for. It's a tedious process. Okay, well, I will tell you that one other pro is that, like, if you were trying to like the steps that you can do the steps like the same way every single time. There's like not like sort of a one size fits all approach. We don't have to really like think about it. Like with elimination, you think sometimes, okay, which variable is easier to get rid of, and oh, what are some ways to make these numbers the same? In this one, the 5-step process is, and this might be what Talia was getting at, the 5-step process is going to be just do this, do this, do this. Like you could program a computer to do it, and it's just always the same steps. There's hardly any decisions to make. Although we did see that if you want to avoid fractions, you could swap 2 rows or things like that. But in general, there's not that many decisions to make when you're doing it. Well, today we're going to see how we can do the Gaussian elimination process, the logic of it, but with a lot less writing. And it has to do with a concept that is a huge concept in math. And we're actually going to be working on aspects of this concept for the next 4 weeks. So it's the longest unit of the semester. It's actually the longest unit of the year. It's about 20 lessons, I think, 15, 20, 18, 20 lessons on what's called a matrix. Now, if you took the SAT 2, you probably have some familiarity with matrices because they're on the SAT 2 a little bit. Just from a group chat point of view, have people experienced at least this concepts of matrices from preparing for the SAT2? I see on Zoom there's this kind of like polling feature. Did you learn about matrices already a little? Just want to see if this works. If this works, this will be a nice thing to do in general. Let's see what happens. Add a question. Okay, I don't think I know how to use this. You have not created any polls yet. Oh well, I don't think I'm going to be able to make a poll because I said add a question. Let me try one more time. Have you learned about matrices a little? Sorry about this taking a long time. It's my first time doing this. Just want to see what happens when I do this. Okay, that doesn't work at all. Sorry about that false alarm. Oh, here it is. Okay, just want to see what happens. This is just our experiment. Have you learned about, oh wow, how cool. Okay, so we have a new thing that we can use. I think on the video we won't be seeing this, but doing a poll, and it looks like about half and half between people who have experienced matrices and people who haven't. 18 out of 24. This is great. Okay, so this will be a feature I will be adding to lessons in the future. I'll have the questions planned ahead of time. Okay, so a matrix, I guess in the most abstract definition of matrix, it's a bunch of numbers that are arranged in a rectangle. So here is, oh, and a matrix has dimensions depending on how many rows and how many columns it has. And the first number is the number of rows, and the second number is the number of columns. So this has 2 rows and 1, 2, 3 columns. These other ones are square matrices, so 2 by 2, 3 by 3. And a matrix, a square matrix, like this one, if along this diagonal here, everything below it is a 0, it's called an upper triangular matrix. So, but at its most abstract, a matrix is nothing more than a bunch of numbers in a rectangle. But when we're going to give meaning to these matrices, they're going to be useful for doing things. And the thing we do with them today is I'm going to show you how they can be used to simplify the Gaussian elimination process. So here's a system of equations from Friday. 2x plus y equals 13. 3x minus 2y equals 9. If you take a system of equations and you take the coefficients, in other words, the 2, the 1, the 3, and the negative 2 are the coefficients of the x and the y, and you put them into a square matrix, that's called coefficient matrix. If you take the 13 and 9, that is the 2 numbers after the equal sign, and you make that the next column of the matrix, so now I have a 2 by 3 matrix. And you don't have to have this line here, but we generally do put a line where the equal sign was. That 2 by 3 thing that's made by taking the coefficient matrix and putting the numbers after the equal sign as the next column, that's called an augmented matrix. Now, just like there were 3 operations you could do on Friday with equations, where you can multiply an equation by a number, both sides of the equation by a number, or you could swap 2 equations, or you could multiply a equation by a number, add that new equation to another equation, and replace the thing that was added to with the sum. In fact, I think I'm going to go like this here. There are 3 elementary row operations that you can do with an augmented matrix. Oops, I've lost. Okay. Why don't I go ahead and put an arrow here? So now these are called the 3 elementary row operations. You can take a row of an augmented matrix and you can multiply all numbers by a constant and replace that row with that new list of numbers. You can swap any 2 rows, or you can add to any row the result of what you would get if you multiplied a different row by some constant. And only the row that got added to gets changed. And generally we do have a plus here. I mean, you could create a 4th operation with a minus there. It would still be like allowed, meaning that it would, if we added a 4th operation, we'd be able to use it to solve equations. But generally, these are the 3 elementary row operations. Okay, now I'm going to show you how the elementary row operations work. Now there's, what's going on here? Hold on a second. Okay, so what we see here is that the equation, this 2 by 2 system of equations, can be expressed as this augmented matrix. If, I'm not quite sure, let's not worry about these 2, I forget what those are there for. But I did want to show you that if an augmented matrix has a, if you ignore the part, the last column, if you just take this part of it, which is a square matrix, and if it's upper triangular, you could then turn that matrix back into a system of equations. And if you have something like this, where the diagonal is all 1s, and all other elements are 0s, that's what's known as reduced. This one is called row echelon form, if it's upper triangular. And if it's got 1s down the diagonal and 0s everywhere else, not including this thing, then it's called reduced row echelon form. So we have a couple of definitions there. Okay, what I'm showing you here is that if you do the row operations, oh, now I see what all this stuff here is. So here's the initial system of equations done as an augmented matrix. if you do any of the row operations, you'll get a new matrix, but the solution to that matrix, the system of equations that it's related to, will have the same solution as the original. So here, let's say I want to actually do, I want to convert this into upper triangular. And the first step of converting this upper triangular is to change that 2 into a 1. What's the sort of classic way to change that 2 into a 1? Like if I want to do it in one step, what is the way you would do that? You could type that into the comments. That's right. If you divide everything by 2, but what's the problem with using that row operation? Why might you not? Yeah, you may not want to deal with fractions. So you could, another way you could do this one is use row operation number 3. I could turn, I look down, I see this 3 here. So 2 minus 3 is -1, or -3 plus 2 is 1. So if I do row operation, negative row 2 plus row 1 into row 1, in other words, the third row operation, it turns into this. And now it's not a 1, it's a -1. Then, now good news for you, making it a -1 is actually just as useful as making it a 1. And you don't need to make, the only reason we've been making it a 1 is it makes it really easy to zero out the other number. But -1's easy also. Because if it's -1 and I multiply it by exactly this number, 3, multiply row 1 by 3 and add it to row 2 and replace row 2 with that, then I end up with 0 here. And I've created upper triangular. So upper triangular, it's okay if this thing's not a 1. It could be a -1. I would say either make it a 1 or a -1, whichever is sort of easier for you to do. And you can see here that it's turned into upper triangular, which now I can turn back into a system of equations, but it's going to be an upper triangular system of equations. So I will be able to solve it really fast. Now let's look at the 3 by 3. First thing to notice is it's going to be a lot less writing, because writing the 12 numbers in the matrix is easier than writing the 12 numbers in the matrix is easier than writing the system of equation, because you don't have to put the x's, the y's, you don't need to put the z's, and you don't need to put the pluses and the minuses or the equal sign. So it's just less writing. Now it's still going to be the same 5-step process, meaning turn this to a 1 or a -1, turn that to a 0. All right, plus minus 1 there. Change this to a 0. Change this to a plus or a -1, and then change that to a 0. So those are going to be the 5 steps. And good news is that the first step is already done. And now I'm going to move on to the second step to make this 2 into a 0. Can someone type in, using like the shorthands with the R's, what row operation would you do to turn that 2 into a 0? Okay, so Jonah, I like what you wrote. You have sort of a 2-step process, -2 R1 and then R1 plus R2. But I'd like you to write it as one step. The reason why is because row 1 is not actually going to change. Only row 2 is going to change. So while it's true in your mind, I'm going to go like that, turns into row 2. So row 1 doesn't actually change in the sense that we don't literally change it to 3 or whatever, -2, -4, -2, -6. But in our mind, that's what we do. -2 times 1 is -2 plus 2 is 0. -2 times 2 is -4 plus 1 is -3. -2 times 1 is -2 plus 1 is -1. -2 times 3 is -6 plus 16 is 10. Now I'll just make the arrow going downward. Step 3 is to turn this 1 into a 0. Can someone type in the 1, like a 1-line row operation that will turn that 1 into a 0 while leaving everything else the same? That's right. Minus R1 plus R3 becomes R3. So minus 1 times 1 is -1 plus 1 is 0. Minus 1 times 2 is -2 plus 1 is -1. Minus 1 times 1 is -1 plus 2 is 1. And don't forget this guy. Minus 1 times 3 is -3 plus 9 is 6. Okay, now step 4 is to change this 3 into either a 1 or into a -1. And what is the most efficient way to do that? You could type it in to the chat. I think we can go simpler than that. Yes, swap 2 and 3. Chelsea, call them R2 and R3 in this context. Jonah, I want to say something about the R2 plus R1. The problem with it, because you are allowed to do other operations to make this a 1, but if you actually did R2 plus R1 into R1, it would mess up the 0 that you got in the second step. So you do want to be careful. For instance, when you do swaps, you only want to swap, you don't want to swap with a row that's like this one here. Like imagine there was a 1 where this 2 is. It wouldn't be a good idea to swap those 2 rows because it would kind of mess up the 0. So you would only want to swap with a row that's below it because that will also have a 0 in this spot. And that's why swapping row 2 with something below row 2, in this case, row 3. So our next step was to swap R2 with row 3. Oops. That's what we have. And then finally, well, I have it written already, but what row operation did I use to go from here to here? You could type it in. Now I have a -1 there. I could leave it as a -1. I don't need to turn that to a 1 because it's just as easy to make a 0, make this into a 0 if there's a -1 than if there's a +1. Okay, so what row operation occurred there? Well, if it was a positive, yeah, you're right about that. Because this is a -1 already, if you do -3 R2 plus R3 into R, it has to go into R3. That's why people usually don't write the R3. It's just assumed that it goes into this one. You can't replace it into a different row. And then we end up with this. And now we've achieved the 5 steps. It is now upper triangular. And now I could turn it back into the system of equations. -4z equals -8, or z equals 2. Minus y plus z, which was 2, equals 6. So I'll just say y equals -4. And the top equation is x plus 2y, which we already know is equal to -8, plus z is equal to 3, or x equals that right? I feel like I made a mistake there. Minus 8, 5. So 5, negative 4, 2. Okay, so as you can see, it's the same logic as we did in the lesson from Friday, the Gaussian elimination, but it's less writing because you don't have to write the x's. Now, matrices are a lot. We're going to do a lot with matrices, and we're even going to come back to this application after we learn more like theory about matrices and arithmetic and multiplying matrices. A lot more is going on than just, oh, this is a way to not write the x's, y's, and z's and pluses. There's a lot going on that lets us do these row operations, but for now, that's how we're thinking about it. Okay, I want to show you now that we can use the graphing calculator. I want to show you how you can use the graphing calculator to do matrices. So let me come over here and share. Okay, so here's the graphing calculator. And it's pretty clunky even to use the graphing calculator, but I do want to show you, how it works. So first of all, there's 2 ways to put a matrix into a calculator. One way is to say second and this inverse key, and the matrix menu comes up. And you see here 1, 2, 3, 4, 5, 6, 7. I'm just going to go over to the right and say edit matrix A and hit enter. And then it asks me what are the dimensions of this matrix. And the one this one I just did, this augmented matrix, was 3 rows and 4 columns. So I say 3 by 4. And you can see that as I do that, the matrix, we get a bunch of zeros in the matrix. Now, when you want to put in the augmented matrix, you could push 1, and you could push enter actually, and it will go to the right. So 1, 2, 1, 3, and then 2, 1, 1, 16, and then 1, 1, 2, 9. And if I quit, if I do second quit, and then from this main home screen, I say second X inverse, and if I just go over to names where it is and push 1, the A will come up on the screen, and if I push enter, it will show me the matrix 1, 2, 1, 3, 2, 1, 1, 16, 1, 1, 2, 9. Now, you can do row operations with this augmented matrix. I'll show you how that works. Let's say I wanted to turn this into, I wanted to do the actual row operations we did. So I want to do -2, row 1 plus row 2. The way you do that, it's really, really clunky, but I'm just going to show you how it works. You go second matrix, and you go over to the math. And in the math, there's a whole bunch of stuff. Det, T, dim, fill, identity. Well, if I scroll down, the thing on the thing on F times row plus is the 3rd row operation. So if I go times row plus, I hit enter. And then it wants me to put stuff in. And there's 3 things you have to put in. You have to tell what matrix, because you could have multiple matrices. So what matrix, I have to put in what do I need to multiply it by, and I need to put in what row is going to get what row gets added to. Sorry, there's 4 things. So I want to multiply the first row by -2 and add it to the second row. They made it so you first put in the number I'm going to multiply. So I'm going to multiply -2. Then, I don't know why they did it this way, but then they want to know, hey, what matrix are you dealing with? Like that should be like the first thing you put in, but they didn't make it that way. So second this, and I say matrix A. Then they want to know what row are you multiplying by? Well, row 1. And what row are you adding it to? Row 2. Now I don't want to, if I just push enter, it will do it. But I want to also store the results. I want to change matrix A. So I also say store in second inverse 1. And if I do that, it will perform the row operation and it will update matrix A so that it's like that. Now I can do, I'll just do here now. So now if I go second enter, I've got that whole row operation again. But this time it's row, I want to multiply row 1 not by 2, but by -2 insert 1. And I want to add it to row 3. And now I have, oh, I have a double negative there, which is not what I wanted. That's okay. I could fix that by changing it to a single negative. I didn't even know you could put double negative like that. I'll make it a single negative. And since I already changed the matrix, I'm going to have to also make this a 2. Okay, and now I'm there. Now to swap 2 rows, that one's easier. I go second matrix math. And if I go down here, I want to swap rows 2 and 3. Well, C does that. And for row swap, we first put in what matrix we're dealing with. It's very, I don't know who like thought, user interface, that this is to not make that for all of them. And just say which 2 rows am I going to swap. So swap row 2 and what, row 3. And don't forget, we want to also store it in second matrix A. If I don't do that, it will do it, but it won't save it into it. So now those rows are changed. And now, finally, let me just show you, because there's also the row operation. Let's say I do want to change that -1 to a 1, just even though I don't really need to. I want to show you at least how to do the third row operation. So second, that, math, and if I go down, there is a thing that says times row. So for times row, for this one, you put the thing I'm going to multiply by first, not what row, what is the constant I'm multiply by. Then you put in the which matrix I'm dealing with, and then you put which row of that matrix I'm multiplying by. And don't forget to store it back into matrix A. And now to finish this thing out, I'm going to go second enter to go to one of them where I have the multiplication. Oops. Another one. And I want to multiply row 2 by the number 3. So I don't want this negative. Okay, I'm multiplying 3 by row 2 in matrix A and adding it to row 3. And as you can see, it is now done. Now, you might be looking at that and saying, that was harder than doing it by hand. Well, using the calculator, if this is not like the main thing we're going to be doing, I just wanted to show you that the calculator has these things built into it. One benefit of the calculator is that it will work with fractions nicely. So you could be sure that it's not going to make any careless errors on the fractions. One more thing I wanted to mention about the calculator is that there's another way to input, easier way to input a matrix into the calculator. You push, see, I forgot how this works. You push alpha. How do I get to that menu? Hold on a second. Yes, you push alpha and the top left one, which is y equals, wait, no, you push alpha and you push zoom. Alpha zoom creates this menu that says matrix. And then you can set the dimensions. Let's just say I want to make a 3x2 one. And I go to OK, and you'll like this. It brings up the matrix like this. For this, though, you can't push enter. You have to push the right key to change the different things. Don't push enter because I think it just ends it the second you push enter. And nice feature here, if you just push enter, it just displays it, but you'll want to then store it. Oops, I pushed second by accident. Instead, I want to push store into second matrix. Let's say I stored into B. And now it's there and it's stored. I can come here if I want to see matrix B. You could see it right there. I could edit it, things like that. So that's another way to, it's easier. The newer calculators, I mean, like, unless you calculate really old, you have this alpha menu where you can push alpha zoom and get to the matrix. Okay, so that's the main thing that I wanted to show you today. I'm going to bring back up the iPad for a second. Okay, so here's the iPad. And you can take a look. This is me doing the 3x3 system. That's the one I just showed you. But take a look here. This is what would have happened if I decided to change that in step 4, when I changed that thing into a 1 by multiplying by -1/3 instead. Like here I was, let's say, and that -3, instead of swapping, instead I want to just change it into a 1 because I'm using a calculator and it's not fearing fractions at all. This is what would have happened then. And then I could have done the next row operation, multiply row 2 by 1 and add it to row 3. And then at the end, if you push math, enter, enter, into the matrix, then push math, enter, enter, it changes the things into fractions instead of decimals. And then we could solve it that way. The store button, someone asked, is over the on key. Oh, there is one more thing. You'll really like this. There is a really, really big shortcut that I'm going to show you in a second. This was another example I was going to do, but let me come back now. Who's ready for a really awesome shortcut? So here's matrix. Let me get back to my matrix A. Second matrix. I'm going to edit matrix A. And I'm going to change this matrix back into what it was. You know, like when the question started. So this was the one that was 1. Does that work? Oh, good. I could use my actual keyboard. 1, 2, 1, 3, 0, -1, 1. Oh, something went wrong there. Sorry about that. Second matrix. Let's just go to edit. I know I can't. You probably can't type negative with some other way to do the minus sign. So 0, -1, 1, 6. This is just bringing it back to where it was. It's not where it was it? 0, it was. And then, hold on. No. Sorry, everyone. Let me go back to here. It was 2. It was 2, 1, 1, 16. And it was 1, 1, 2, 9. Okay. Okay, this matrix is now back. Second quit. I want to see the matrix that it actually made it in there all right. Second matrix 1, enter. Okay, 1, 2, 1, 3, 2, 1, 1, -16, 1, 2, 1, 1, 16, 1, 1, 2, 9. Okay, we are ready now for the powerful thing. Check it out. Second matrix, math. And down here, there's a thing that says ref. If you say that, and then you go second matrix 1 and push enter. Anyone have a theory of what ref might do? Oh, sorry, everybody. New share. Thank you. I'm on the calculator. Okay. So here I re-input the original 1, 2, 1, 3, 2, 1, 1, 16, 1, 2, 1, 9 into matrix A. And I went second matrix, that's not matrix, second matrix, math, down here to ref, and then second matrix A. Okay, anyone have a theory of what ref might do? I haven't hit enter yet, but what might REF stand for? Reference, maybe. It's an acronym for 3 letters, for 3 words. If you look back at your notes, close. Row echelon form. In other words, you see it made it upper triangular. In fact, let me do that and also say math, enter, enter. See that? Row echelon form. Now there, it does the problem automatically. Well, there's still some work to do because row echelon form takes a little bit of work. But what's better than row echelon form? Reduce row echelon form. Well, check this out. Second matrix, math. Underneath the REF, there's one that says RREF. Well, if this works, it'll be ultimate, right? Second matrix 1. And all done. Because if it's in reduced row echelon form, the system of equations that relates to it is z equals 2, y equals -4, x equals 9. Oh, well, that means that the 5 that I had from before was wrong because the y was not 4, but it was -4. If you come back to the iPad one, I had an error there for those who were following along at home. Let me come back. Let me go back to the iPad to show people that. So I have had an error there. Sorry about that. But so the lesson today was that there is a really, really easy way to do matrices for systems of equations on the calculator using the ref and the RREF. This thing over here, when I did it, where is it? Maybe it's back here. I don't know where it went, but I know that I thought that it was, I know that I thought that it was 5. Yeah, over here. So the problem was, it was negative y plus 2. Oh, the -4 was right. So the problem was x plus 2y plus, So x, which we don't know, if y is -4, 2y is -8, and z, oh, I see, z was not 6. Z was 2, and there was the error. So x actually ended up equaling 9, not 5. Okay, so that was the lesson for today. What we learned is that there are these matrices that one thing about them is that they could make it easier for you to, less writing. But there's also these row operations that for now seem like just shorthands for the equations, but there's actually a lot of sophisticated stuff. And some textbooks on this course, this linear algebra course, some textbooks don't introduce this application of matrices until like 200 pages into the book, because there's a lot of theory that's actually needed to prove what's going on, what's really going on. For now, it's just a shorthand, but we will, over the next couple of weeks, learn a lot about matrices and come back to this application and see like what's really going on with row swaps and things like that. Okay, so that's going to be today's lesson. Let me pause or stop the recording.